Okay, hello everyone out there in cyberspace, and welcome to this webinar broadcasted to you from the Nordic Bioplastics Association. I am Bo Wallteg. I'm actually the editor-in-chief for the magazine Emballage and some of our net pages, but I'm also one of the founders of this bioplastics organization. We started it in 2012 and we have just below 70 member companies today. We do have a lot of cooperations with companies and with other organizations like the European Bioplastics Organization based in Berlin, and also with their regional network. We do this kind of webinars 5-6 times a year, and it's been very popular, and I hope you will enjoy this afternoon also with us. The meaning with the Nordic Bioplastics Association is actually to create a network between industries that produces bioplast or companies that are interested to use bioplastics, like brand owners, for example. You're all welcome to be members in the organization and learn more. We are a very active organization with a lot of webinars, with a lot of meetings, with a lot of seminars live from scene when that's allowed from a COVID point of view. And we are also doing a lot of lobby business to decision makers. Right now, we are focusing on Swedish politicians in the government, and we are building up a schedule for them to listen to what's the good things with bioplastics, and that will happen during the coming months. Sorry. We are also active on many shows around, especially in the Nordics, and the next one coming up is a plastic show in the city of Malmö in a couple of weeks in the beginning of December, where we are going to be presenting from the stage and also have our own stand. So I hope for the future, if you like this and if you're interested in bioplastics, you will become a member and you can learn much more on our website about this. Just to mention, the next big meeting where we hope to be able to meet physically and not only on the web will be in the end of March, when we have our annual meeting, and we will send out more information on that when we know exactly where and when. And before we start the program today, I just want to say you can ask questions in the chat, no problem. I will try to put some of them to the presentators when if time allows it. But if not, they will get the questions and they will be able to answer you personally after this. And yes, everything will be recorded and the presentations will also be placed on our website, but it might take a week or two before that is done. So you can listen again and see the presentations if the presentators agree to share it with you. So I think we will stop me there and I will present the first speaker, and that is Mr. Michael Thielen. He's the owner and the editor for the magazine, Bioplastics magazine, based in Germany. And it's actually a magazine that you will have for free for a year if you become a member of the Nordic Bioplastics Association. We will arrange that, so you will have the magazine free for 1 year. Michael Thielen will give us a bioplastic market update and also talk a little bit about some new products. So I think, Michael, please, the screen is yours. Welcome.
Okay, yeah, thank you very much for the introduction, Bo. I will start right away with sharing my screen. And go ahead. Yeah, my name is Michael Thielen. I am the publisher of Bioplastics magazine, as Bo said. Bioplastics magazine is a bi-monthly magazine, English language only, and it's distributed 6 times a year, globally to 92 countries, and it covers everything that you need to know about bioplastics. I am also the publisher of this Basics book. It's an affordable book on bioplastics, basics, applications, markets. It's available in English, in German, and also soon in Chinese. So much about the commercial for my own products. Let's start right away. I would like to give you an overview about what are bioplastics, because there are still a lot of misconceptions around. and why I think we need them. Okay, why do we need bioplastics? So one reason I think is the oil price. On this chart, you see the oil price development over the last 15 years. And you see that, and you all remember that in 2008, we had this peak at $145 per barrel, and then it went up and down and up and down. And nowadays we are somewhere here, around $60 per barrel, but nobody knows, will it go up or will it go down? So the oil price is one reason why I think we need bioplastics. The second reason why I think we need bioplastics is this. Does anybody know what it is? Of course, you cannot respond, and this is why I will tell you. This is the average temperature of the Earth from 1850 to more or less today. And you see the darker blue, the colder it was on the Earth, and the darker red, the warmer it was on the Earth. So the topic is clear. The climate and the climate change is the other reason why I think we need bioplastics. Everybody knows that the influence of incinerating petroleum-based products, and this includes fuels as well as plastics, on the climate is well known. However, if you have products made from renewable resources, from plants, these can only release that amount of carbon dioxide to the atmosphere that they had sequestered during their growth phase by photosynthesis. And this is what we call CO2 neutral, carbon neutral, climate neutral. And the third topic I think is important to mention is the waste problem. We all know these pictures. There's the garbage in the oceans, and in the stomachs of animals we find plastics. So waste really is a problem. And of course, this leads us to microplastics, microplastic everywhere. I have here a screenshot in German language. With each meal, we eat 100 pieces of plastics, or especially for us in Germany, very important, finding plastic fibers in beer, that's a no-go. However, it is questionable whether bioplastics can be a solution here. This, of course, needs to be discussed separately because I don't have the time today. Now I come to the definition. What are bioplastics? And here I have a chart, and I start with what are no bioplastics. And those are the plastics that are neither biodegradable nor made from renewable resources. So not degradable, but from petroleum. These plastics are no bioplastics. And then we have this group here on the top right. These are the new kind of bioplastics. They are made from renewable resources, and they are biodegradable or compostable. But also this group we want to call bioplastics. These are made from renewable resources, but they are not biodegradable at all. I come to that in a few minutes. And also this group we want to call bioplastics. These are made from petroleum, but they are completely biodegradable or compostable. So this and this are what we call bioplastics. If you want to call a bioplastic compostable, you have to make sure that it fulfills certain standards like the EN 13432 or the ASTM 6400. Now I would like to give you some examples for bioplastics. And we start with the quadrant in the top right corner, bio-based and biodegradable. And the bioplastic with the biggest market significance today is PLA. PLA, or polylactic acid or polylactide, is made from starch through fermentation. So starch is fermented into lactic acid, that is converted into lactide and then into polylactide. The next group I would like to mention, very interesting new kind of bioplastic, relatively new, is PHA or PHAs. That's a family, polyhydroxylcanoates. It's a family of polyesters which are made by microorganisms who eat, for example, sugars or starch or edible oils, and store energy in their body in form of these polymers. And that up to 80% of their body weight, as you can see from the picture. You can make interesting products out of it. Here I have a picture of some injection molded products, but you can also make fibers, films, you name it. We are still in the group of bio-based and biodegradable plastics, and the next is the starch-based bioplastics. And starch itself consists of two polymers, namely amylose and amylopectin. And this can be modified and transferred into a plastic material, which is called then TPS or thermoplastic starch. Products are, for example, the well-known bio-waste collection bags, or also these loose fill chips that you can use to protect your goods. Still in the same group, bio-based and biodegradable, are cellulose-based bioplastics. They are made from wood cellulose, in many cases from wood residues or from sustainably managed forests. And for example, the pen that you can see on the bottom is in crystal clear injection molding grade. And on the right-hand side, you see a film product that is also made from a cellulose-based plastic. Relatively old and relatively new are bioplastics made from casein. Very early in the last century, casein was already used to make products like buttons or knobs to replace ivory or horn. Today, casein from raw milk, which is no longer suitable for sale because it cannot be used as food according to current legislation, can be converted into a bioplastic material. And that can be converted then into fibers to make interesting and very, very nice textile products, but also microbeads for cosmetics or film products, and even water-soluble products can be made, for example, the film to wrap these dishwasher tabs. The next in this still the same group, bio-based and biodegradable, is lignin-based bioplastics. Lignin, for example, combined with natural fibers by the company Arboform, by the company Tecnaro, the brand name is Arboform. They call it injection moldable wood. But it can also be blended with PHA, with PLA, with waxes to make a hell lot of different other products. Now we come to the next group. They are not bio-based, but still biodegradable or certified compostable. And one example is Aliphatic Copolyester, PBAT, very, very active in the market, but also PBS or PBSA or others. Now we come to the next group on the top left corner. These are bio-based, made from renewable resources, but not biodegradable. In the first slide, I have some polyamides. PA11, for example, has been known for many, many years, made from castor oil, very good for fuel nipples or fuel lines. And the next polyamides that were developed were the PA410 or PA610. Here, the 10 component, the decarboxylic acid, is made from castor oil or from soy oil. So these polyamides, also the two photos here show examples, are partly bio-based. Now, if you also make the diamine component out of glucose, for example, you get PA510, and this is completely bio-based. And there are more polyamides available, PA1010, for example, and others. Also very interesting is this group, bio-based, not biodegradable, still the same group on the top left, biopolyethylene. Bio-PE can be made 100% from sugarcane. In Brazil, the people have a long experience with bioethanol from sugarcane because they drive their cars with it. And this bioethanol can then be converted into ethylene and then be polymerized into polyethylene. Bio-PP, biopolypropylene, can also be made from sugarcane via bioethanol. Or there are also other production routes, and this has been available, I think, since 2019 or so. PET, until now, at least partly bio-based, so the 30% by weight monoethylene glycol can be made also from bioethanol, but the 70% terephthalic acid could not so far be made bio-based. But Coca-Cola, I think just this week, or last week, released a press release where they introduced prototypes of 100% bio-based PET. So with their partner Virent, they also have now available bio-based terephthalic acid. Another interesting topic is bioplastics from waste streams. Many people say, please don't make bioplastics from plants that can also be used as food or feed. I come to this topic again towards the end of my presentation. But instead, you should use so-called second-generation raw materials, such as stems, leaves, peels, bagasse, etc. I just wanted to mention that. Preferably, you should try to use all kinds of waste streams to make bioplastics, right? But that is possible. Okay, my next topic is market figures. I was asked to provide some market figures, and I have all these figures from the Industry Association European Bioplastics. The first slide shows the global production capacities for today, but also projected until 2025. And you see that the capacity is still significantly growing. All bioplastic categories will grow, but the biodegradable, interestingly, is still growing faster. But please be aware, these are estimates based on announcements of companies. Not all of them might come true. But still, we are expecting a significant growth. This shows the global production capacities by market segment. And you see that the biggest market segment is packaging, followed by consumer goods and textiles, but also application areas like automotive, building and construction are using bioplastics. This picture shows the global production capacities by material type. And here you see that the biggest groups are PLA and starch blends, but also the others are relatively interesting market shares. This shows the same, okay, sorry. This picture shows the biodegradable plastics 2020 versus 2025. And here you see that especially this light brown PHA is significantly growing, but also PLA is growing and PBAT is growing. The others are more or less stable. Okay, I think that was it about market figures. Now I come to applications. I would like to show you a slideshow of interesting old and new applications. The first I would like to talk about is the field of applications in agriculture and horticulture. Here you can imagine that biodegradability has a significant advantage. If you look at the mulch film, this does not need to be collected and cleaned after the harvest, but it can still be plowed under and become a fertilizer in the ground. Planting pots, obviously, and also these tomato clips, which can be disposed of together with the green waste after harvesting the tomatoes, which makes disposal much, much cheaper as if they were made of polypropylene, for example. The next is durable application. I have a lot of pictures here about durable applications. For example, this CD box and the CD or DVD. The DVD itself is made of a bio-based plastic. Car parts like floor mats. You see, this is an old picture, but mobile phone housings have been tried to make of bioplastics for a long while already. Other car parts, interior and also exterior today. I mentioned these fuel nipples in the car, the seats and also the textiles for the seats can be made of bio-based plastics. Consumer electronics, you see here, for example, in the top right corner, the older ones among us might remember the Sony cassette Walkman. And this last examples of the Sony cassette Walkman had a housing of PLA. Also here, interesting products were on the market and are still. Toys, very interesting field of applications. A lot of toys can already be made. We just recently had a very successful bio toy conference. In the lower left corner here, you see the bushes and trees by Lego, made from bio-based polyethylene, as is this truck, the sit-on truck, or these toys here, very rigid bio-based polyethylene, but also biodegradable plastics are sometimes used. Textiles. This wedding dress on the left has been around, I think, for a decade already. Swimsuits, men's business shirts, baby shoes, you name it. You can make any kind of textiles out of these bioplastics, because most of the bioplastics are polyesters that can be spun into fibers. Here, of course, for all these durable applications, the biodegradability is of no interest. On the contrary, for durable products, the bio-based origin, the renewable resources, is of utmost importance. And of course, packaging. Packaging as one of the first and still main fields of application. I show you a number of examples: rigid packaging, thermoform packaging, clamshells, thermoform trays, foam trays. Here in this picture, you see a lot of different reusable or single-use thermoformed products made out of PLA. But starch-based thermoplastics as well as PLA can also be foamed and then extruded into sheets, and these can then be thermoformed into packaging products. Films, flexibles, bags. I just want to mention the shopping bag. If it is made of a biodegradable plastic, a compostable plastic, it can be used as a waste, as a bio-waste collection bag in your kitchen and have a second very important use. The next section is bottles, for example. All these bottles that I show here were already on the market, and many of them already disappeared, but for different reasons. Still, some of them are available in the market, like, for example, this Sant'Anna water bottle in Italy, and also others. I mentioned the Coca-Cola plant bottle. This is an old slide. As I said, both the monoethylene glycol and the terephthalic acid can now be made of renewable resources. I think it's not commercial yet, but Coca-Cola announced it. But there is an alternative coming up. It's also not available yet, and that is to replace the terephthalic acid with furan dicarboxylic acid here, FDCA. And then you have a material, this is not PET, but it's PEF, polyethylene furanoate. In this picture, you see how it's made. The terephthalic acid is replaced by FDCA, and PEF is the material that you will get. And it has very interesting properties if you compare that to PET. The oxygen, carbon dioxide, and water vapor barrier are significantly better than PET. The thermal properties are better than for PETs. And the mechanical properties, for example, 60% higher modulus. But it is a 100% bio-based polyester. I think if you are in the field of PET, then you should keep your eyes open also for PEF. Now, a few recent packaging highlights from the world of bioplastics. Here I have a bottle made of WPC. Most of you know WPC, wood plastic composite from deckings. But this guy from Doyle Ecotech in Korea, he made a shampoo bottle with a pump valve out of WPC. Multi-layer laminates or co-extruded. In many cases, one single bioplastic cannot fulfill all the requirements of a packaging. Then you can make laminates of several bioplastics, and each layer contributes to a certain task. One is for the strength, one is for the barrier, one for the sealability, printability, etc. Also, just a few examples, coffee capsules. Many coffee capsules have been around and are still available, and more are to come. I just want to show you some pictures here. Coffee capsules, where the barrier that is needed for the coffee is either in the capsule, or as in this case, the barrier is in this overwrap. Next example is breathable window film. These transparent films, many bioplastics have a very poor water vapor barrier, but in this case they call it breathable, and it's an advantage. So bread or cheese or salami or fruit, vegetables can have a longer shelf life. Next example is particle foam. Particle foam is well known. You know EPS or styrofoam, but this is particle foam made of PLA. This ice cream box has won the Bioplastics Award recently, but you can also make other particle foam out of it. Also from EcoVio, this is a blend of PLA and PBAT, can be converted into particle foam. It was introduced a couple of years ago at the K Show. Now, I mentioned that before, land use availability. Do we have enough land to produce crops for bioplastics? Or is there a competition with food? I have here a slide also taken from European Bioplastics, and you see that the whole circle here is the global agricultural area. And you see the biggest part, the yellow, orange part, is pasture to feed our cattle to make meat. And then this big part here is also for food and feed. And just this small, very thin green line is for bioplastics. So last year, the production capacity needed 0.015% of the global agricultural area, and projected to 2025, it's 0.02. I think there is no competition with food and feed. Now I come to my concluding remarks, and then I will be finished. I think with plastics being just 4 to 7% of the global crude oil consumption, and 5 to 10% today of potential substitution of fossil-based plastics by bioplastics, today we are at around 1.3, 1.5%, but it's projected that 5 to 10% could be substituted. Bioplastics cannot save the world from oil shortage, but with an oil price that I think is rather to rise further than go back to $20 per barrel or less, eventually oil will become so expensive that the plastics and the packaging industry is well advised to have an alternative from renewable resources. And we can contribute to reduce the greenhouse effect. Yeah, that was it. I thank you very much for your attention. And of course, I will stay around for questions if you have any.
Okay, thank you very much, Michael. Very fast, very quick presentation, a lot of information in a short time, but interesting. We don't have a lot of questions, but I do get one that I'm not surprised that it comes up because it's about the PEF material.
Yes,
It's not commercial available yet? Did you say that, or?
No, it's not available yet. But several companies are working on it. There is one company in the Netherlands, Avantium. They have a pilot plant running, I think, and they are working on upscaling to commercial grades. And just recently, you can look it up on our website. There we have the news section. There was a news about Colon and Origin materials. They are also cooperating now to make this commercially available pretty soon. But I don't expect it to be commercially available before 2024.
Okay. We have another question. Do you know if the EN 13432 norm is under evaluation?
I think yes. I think the makers of this norm are sitting together and think about to modify that. But I don't know anything about the progress they made.
Okay. What do you think about the ban of compostable plastic alternatives as single-use plastic articles?
Yeah, I think this is if you look at the single-use plastic ban from the European Union, this is pure actionism. It's not driven by any serious thoughts. The problem is that they don't listen to the experts like those from European Bioplastics or us from the magazine. I think nobody of us is throwing straws in the ocean or is throwing bags in the ocean. So to ban these single-use items is pure nonsense. I think the most plastics that ends up in the ocean comes from purely managed or poorly managed landfills in many countries of the world, where the landfills are not covered, where the landfills are not managed properly, and the wind comes and blows away all those bags and parts into the rivers, and then they end up in the ocean. And it's also not a good idea to ban all kind of single-use plastics and not make any exemptions for really, really advanced new developments of biodegradable, compostable, and even marine degradable bioplastics, which, from my opinion, should be exempted. But as I said, these policymakers, this is my personal opinion, they for whatever reason, they don't listen.
Okay, yeah. Can compostable plastics be recycled to new products, or is composting the only way?
No, I think I dare say that all thermoplastic materials can be recycled. During the production, it is done anyway. So if you have injection molding, then you have the sprues. If you have blow molding, you have the squeeze off waste. If you have films, you have the cut-offs at the edges. They go directly back into the process. So they are being recycled. If it comes to post-consumer recycling, recycling is in most cases is a question of number one, sorting. Can you sort out those to be recycled plastics? And then if you could, I think technically it is possible, but then still, will we have enough material to recycle? I think there is always a critical mass before recycling makes economically sense. Technically, it works for all plastics and bioplastics, but economically, it only makes sense if you can collect, I don't know, 10,000 tons. There is a recycling plant in southern Belgium. They have a chemical recycling plant on their premises for PLA, but they say it's not running because also we need 5,000 tons before we can economically run this recycling plant. So more and more bioplastics must come into the marketplace so that we can collect them, can sort them, and recycle them. Technically, it's possible.
Okay. A question from me, what do you say about the availability of raw material these days? Because when I talk to companies, they say that it's very difficult to find bioplastics today. And it seems like there need to be an expansion of the production capacity in many ways to be
yes,
able to support. Today it's a problem, and that must be a hurdle for the development of material as such.
Yeah, that really is a problem. Thank God there is a high demand, so that companies can invest and do invest in expansion. You heard that Total Corbion is building their second big plant. That the first 70,000 tons plant in Thailand is running. They are building their second plant, 75,000 tons per year in France. NatureWorks is also planning a second plant. This, of course, takes time and it needs to be financed. So it's a thing of bringing product to market, sell it, have income, and then you can expand. But many companies are expanding. Also in the PHA arena, big plants are being announced to be built.
Yeah. Because I mean, this is a problem for the big brand owners. If you look at Coca-Cola, if they should consider to go direct only into bioplastics, they will take all and much more because they need so much material. So it's impossible.
Yeah, and this is also the case why PEF is not commercially available, because when they want to scale up, they want to scale up to really huge production plants to fulfill the market needs.
Okay. Well, thank you, Michael. I think we need to continue in the program. There are some more questions. I will send it to you and you can see if you can answer it, and then we can send it back to the people who's putting them here. So please, thank you very much for this. I know you have to run because you have a deadline. So take care of it and produce a new magazine and we will read it.
Yeah, thank you very much.
Okay,
and good success for the rest of the event.
Thank you very much. Bye-bye. So then let's continue in the program. We have a small change, not with the topic and not with the company, but with the speaker. It was supposed to be Mr. Patrick Zimmerman from FKuR who was going to do this presentation, but there is a change. Instead, it will be Mr. Eike Langenberg from, he is technical sales manager in Germany and Scandinavia. So he will take this presentation. I'm quite sure he will do it as good as Patrick would have done. So Eike, welcome to talk about biopolymers in the context of circular economy.
Thank you, Bo. So let me do some words on my person. So my name is Eike Langenberg. I am technical sales engineer, and I'm responsible for the market in Germany. And I'm also partly responsible for the Scandinavian market. So that's why I'd like to introduce you and share my screen. So, biopolymers in the context of a circular economy. I think the circular economy topic rised in the last couple of years because of huge wave in the politics also, and everybody's talking about the nature, carbon dioxide going to the atmosphere, and so on and so on. And yeah, we as a plastic compounding company, we are specialized on producing biodegradable and bio-based plastics, and we also have specialties such as TPE, and also we have the ability, as we are a compounder, that we do customized plastic solutions for different kind of market applications, for example injection molding, extrusion, and blown film extrusion also. And we do have distribution rights for a couple of different polymers, such as the green PE from Braskem, for example, and also BioPatch from the company FKuR. And yeah, we are a medium-sized group of companies, and so the term FKuR, it stands for Research Institute for Plastics and Recycling, actually. And we've been founded in the early 90s as an institute. And so while the 90s ended, we had a cooperation with the Fraunhofer Institute. And then the journey with the bioplastic began. And we did a lot of compounding trials, and then we have brought our first products to the market. And as you can see here on the top left corner, this is our these are our facilities right now in 2021, and on the right down corner you see our building in the early 90s. So we only had 5 employees in the start, and now we have about 60 employees here in Germany, and we have another production running also in India right now. So we have a joint venture with the Indian company Sky. So, and these are our brands and materials. So we have materials for different application areas, converting techniques, and we are also sourcing different raw materials, of course. So on the top you see our biodegradable plastic compounds. So our first and main product that we see here is our BioFlex. These are PLA and polyester blends for certain processing methods such as extrusion or injection molding. Then our newest brand is the ZeroFlex, which are starch compounds for extrusion processing. And then we have some specialties. Biograde, these are performance biocompounds for applications where the properties need to be considered. So whenever you make use of biodegradable raw materials, you have to adapt the properties to have a material which suits very technical applications. And on the downside, we have the bio-based plastics. So as I mentioned, we are a partner of Braskem, and we are doing compounds out of this bio-based polyethylene. So our brands Terylene and Teroprene, they base on the green PE. And yeah, we have customized green PE solutions, and the Teroprene is green PE based TPE actually. And then we have the Fibrolone, which is a wood fiber compound. So we have wood fiber compounds which could base on different kind of polymers, so according to your needs. And as well, we are distributing certain recyclates to the market. So as a plastic compounding company, we have the ability, as I said, to produce standard formulations and also tailor-made compounds. So we do process different kind of raw materials. So we have here the raw bioplastic granules, additives, fillers, and also reinforcing materials. So this is technically known as compounding. If we mix all of these ingredients together, and we can adapt the mechanical properties, the optics, the bio-based content in the product, heat resistance, and processability, of course. And in the end, we have a tailor-made compound which is suitable for your processing machines, and we have also processing advices and engineers to help you to get the material running. So natural cycles and a circular economy, topic of today. So what you can see here are the natural carbon cycles. So over 1 million of years where the planet existed, it created an ecosystem which was totally balanced, like in every aspect. And onshore, we have the ability to absorb CO2 via photosynthesis. This is what you can see on the left side. So the plants, they store carbon and release oxygen to the atmosphere. So when you have rotten plants and organisms, they are being compressed into the ground, and they are forming today's fossil resources. So these fossil resources, they needed a couple of million years to be produced or compressed. And yeah, on the right side, we have the oceans. So we do not have the plants like on the ground. So we have the phytoplankton, which has a huge volume in the oceans, and it absorbs CO2 from the atmosphere and serves as food for other creatures, and it accumulates on the ground on the ocean. So as well there, it can form fossil resources in the end. So when we humans in the middle, we make use of these natural and fossil resources, such as coal, oil, gas, and wood for transport, electricity, and so on. And we are causing a third linear system, which is not circular anymore, which has a major impact on the atmosphere today, what we can see. So according to the Stockholm University, this results in a release of more than 3 million tons of CO2, which are being released to the atmosphere every year. So why am I telling you this? Because both of the materials, the biodegradable and bio-based plastics, they fit into the circular economy today by closing those natural cycles. So this is being discussed a lot nowadays, and but every value chain today is more linear than circular today. So if we start by the agricultural crop in the middle of this picture, we can see the plant, it stores the carbon dioxide and it releases oxygen. So following the cycle on the right, if we have the biorefinery and processing of the bioplastic granulates, these resources can be turned into several products. So if we use, for example, the bio-based polyethylene, we can have standard products which you can see on the shelf on the supermarket, such as bottles or cosmetics or whatever. And the good thing here is these kind of materials, they can be recycled, and in the end is not more CO2 being released by, for example, incineration, as the plant has taken from the atmosphere. So these materials, they contribute to a CO2 neutral strategy. So on the left hand, if we follow the cycle, we have the cycle of the bio-based and also biodegradable materials. These follow the same routes, and in the end you can have biodegradable and compostable end products. So these products, they can end ideally in the bio-waste bin in an industrial composting plant, or and you can get biogas out of it, or it can biodegrade in the soil. So as Michael already showed you, this is the chart for the bioplastics, and I just put in here our brands. So as you can see, we have the bio-based materials, Thielen, Terraprene on the left side, and on the right side our new Ceruflex and Bioflex for the biodegradable materials. So if we now take a look at the end-of-life options, for the drop-in polymers, as I said, the Thielen, Terraprene, or the green PE, for example, we have the same disposal routes as for the standard polymers. So these can be fully integrated to an existing recycling stream, and they are not identified as a biopolymer. So they have the same chemical structure, and mixing them up will not lead to any contamination. In the end, you have incineration or recycling as an option for end of life. On the right side, the situation is slightly different. So according to national or local legislations and also local composting plants, they can have their own rules on how to deal with bioplastics or biodegradable plastics. So it depends on your local composting plant factory if they want to have those biodegradable plastics or not. So in countries like Italy, it works fine. In countries like Germany, it doesn't work. So this is a huge problem. So, but we have more options than only the composting. So with the incineration, so if the biodegradable materials have a bio content or they have absorbed CO2 from the atmosphere, it has not the bad CO2 figures as their fossil counterparts. If we take a look at the politics, so in the plastic strategy 2030, there have been several goals which have been defined. So the main focus here and the necessity is to improve the reuse, repair, and recycling of products and materials. So obviously the main goals here are to reduce and cut down CO2 emissions and also prevent littering and more trash. And meanwhile, the European Green Deal, it sets more specific targets. So by 2030, the EU should reduce their CO2 emissions by 55% in comparison to 1990. And the main target in 2050 is to be totally CO2 neutral by 2050. We consider the net emissions. So, which impact will these movements have on the society? And how will they change the society? We think that customers will expect more measurable, sustainable products where you can see the, for example, CO2 balance, where the product is derived from, and so on. The design of products, of plastic products, needs to be enhanced. So we should deal with mono plastic solutions and solutions which are recyclable and can have a second lifetime. So no linear products, but circular products. Of course, they expect to have a reduction in CO2 footprint, and recyclable and bio-based or biodegradable solutions, whenever it's considered and brings added value, are highly welcomed. So in the end, most importantly is to have a clear and transparent communication to the end customer. So the end customer, he needs to know what sustainability really means for this product. So in the long run, we think that companies will have to invest in innovation to change their current plastic solutions and bring new solutions to the market. So this brings me to the last couple of slides. So applications and summary. So I will show you some applications from the market, and these are customers of ours. So let's start with the biodegradables. So this is an application from the company Ruplex, and they've invented this biodegradable plastic, which you might know, which is made from coconut fiber and wood or other materials. And they have managed to get it done by extrusion. So they use our BioFlex material, which is biodegradable, and they have created like an open pore structure on the outer surface of this material. So it is beneficial for the plant to grow and climb on this plastic, and it's also beneficial for the biodegradation properties, because if you have more pores and more space for the microorganisms to attack, the material will, in the end, if it lands into in the nature on soil, biodegrade much faster. And as well, this process is material saving because it's not a foam, but it has a low density, so there's less material used for this application. And we have the company Eike Extrusion, and they have a product, it's a binding tube for agricultural things, for tomatoes or vineyards, for example. And they've managed to replace standard soft PVC by using our BioFlex. And we found out that we have the same strength and flexibility as for PVC. In the application, the binding tube, it will fall off after 2 or 3 years when the tree is growing. And in the end, the material is it has a thin wall thickness, and therefore it will not take too long to biodegrade in the soil, actually. And then, of course, as Michael already said, we have the mulch film applications. So these films are certified according to the EN 13432, and they have a good ratio in between degradation and performance. So if you apply them on the ground, they will have good properties for at least 1 season. And then you will dig them under the ground, and they can biodegrade. So summary for the biodegradables: if plastics remain in nature, they should always be biodegradable to not harm our nature. And whenever you consider to make use of biodegradable materials, you should always look on the different properties of these materials, different disposal routes, and also different national legislations in your country. So these should always be considered when selecting a biodegradable plastic. We think that nature knows no waste, so we must see every raw material is a raw material and add value to it and make use of it. And then we come to the applications with the renewables or the drop-in polymers. So this is a company, Biobottle. They have designed a modular drinking bottle for multi-use. So we have here the material, it's green PE. And for the sealing ring, we have bio-based TPE from our terpene product. Then we have the famous building blocks from the company BioBuddy. They have invented these nearly 100% bio-based building blocks, which is quite close to the Lego application. And yeah, they've launched a lot of different products in the recent years, and they became very famous. So a product from Scandinavia, a company Light My Fire, they've decided to design this meal kit as a bio version. So they have made use of our terroline, which is wood fiber filled, and here is the main value to have a slightly lower carbon footprint as well. So we are saving a lot of fossil resources in this application, and it's also a durable product. So a summary for the renewables. So drop-in polymers from renewable resources. This could be for even bio-PE, bio-PET, maybe in the future bio-PP. They can be fully integrated into the circular economy because they have could be recycled, and they fit into the circular economy concept. What we can see, combining renewable and recycled materials could also be a solution to avoid further CO2 emissions. So you can improve the properties of a recyclate by mixing it with a renewable material. So that's it from my side. Thanks for listening, and I'm glad to answer your questions. Thank you.
Thank you, Eike. Interesting, very interesting. We have some questions actually, not very many, but I have one. Are any of the biodegradable plastics possible to get as a water dispersion?
So can you repeat?
Are any of the biodegradable plastics possible to get as a water dispersion?
No, that's not possible.
That was a quick answer.
Yeah.
Another one is the biodegradable bioplastics tunable for different degradation rates?
So we have, the question is if we have a different speed of degradation, is that correct?
Yeah, well, the question is, can you adjust the level of degradation, I think, so how quick it breaks down?
Yeah, we can do so, but I mean, our standard portfolios or our standard materials are designed for good processing. So whenever the customer wants to adjust the speed, maybe we need to make a tailor-made solution or modify our standard solutions for that. So it always depends if our standard materials fit into the application or if we need to change the properties.
Okay. Yeah. And this is maybe a tricky question. How degradable are the plastics in general? Is it the same level as wood or even slower rate of degradation?
It's a good question, but I mean, we have so many types of different wood. So if we take a look at the oak, it degrades quite slow, and we have other wood sorts which degrade really fast. So it's always a matter of density and other properties of the materials. So that's hard to answer, actually. Mm-hmm. And you always need to consider the environmental conditions. So if we are in Scandinavia, for example, we have lower temperatures. If we are in the south, we have higher temperatures. So all of this needs to be considered and cannot be answered in the short term.
I see. I was thinking about one thing. I mean, there's a lot of discussion about microplastics. What about microplastics in connection to your material or bioplastics in general?
Yeah, good question. So all of our materials are certified, or most of them. So we have a clear communication. So if the customer wants to have a fully certified material, he can purchase them by us. And we have the certificate from the institute, and they claim to be fully compostable, and then we do not have any residues left, actually.
So no microplastics?
No, correct.
Okay, okay. I must ask you also maybe the same question I put to Michael. How do you comment the market, the material situation today, the availability of material? I suppose you also struggle with that as a company who sells raw material.
Yeah, I think we are facing the same as for the whole market. So like every raw material is quite rare at these times. So for now, for our products, we have a good access to these materials for the biodegradables. But yeah, of course, we see a growing demand over the last couple of years, and I think the producers, they need to increase the volumes to
So you can actually support raw materials today?
Yes.
Yes, okay. Last question. What is the most common question you get when you come to a company who is interested in bioplastics? What's the first thing they ask you about? And don't say the price.
Why is it not 100% bio-based, maybe?
Okay.
So as we are a compounding company, we always make use of different raw materials, and we blend them. And of course, you have the PLA, which is 100%, and maybe the PHA. But yeah, every time we adjust, we must compensate the bio-based content. Okay,
Eike, thank you very much for this. I think we have to continue now in the program here. So thank you, and see you later, maybe in Berlin in a couple of weeks at the European Bioplastics Congress. Yep. You never know. Okay, thank you very much. Time for the next speaker. We are now actually going to the forest industry. You know, normally the forest industry says don't use plastic, use fibers. And now we have Holmen who says, well, we use fibers to look like plastic, and that's a strange way of turning it. So we are going to listen to Hein van den Reek, who is director of formables at Holmen. And as far as I understand, formables is a quite new division at the company. And you're going to tell us a little bit about Conic, a cosmetic refill concept, a possible fiber solution, as it says. And as far as I understand, it's so far just an interesting prototype. But please, tell us more, Hein.
Thank you, Bo. I will. I do feel a bit strange being in this setting of bioplastics, and I won't mention my colleague's name who seduced me to do this. You know him by name, and later on I'll have a word with him anyhow. But anyhow, yes, Hein van der Reek is my name. I'm allowed to lead the formables department, and that is a very good, yeah, department within Eike. Normally we do in board, we do 2D. Nowadays we do also 3D, and I think that is an interesting perspective. And I don't think that fibers will have all the solutions, nor will the bioplastics have that, or any other packaging materials. We have to strive to new concepts and find ourselves new ways of doing things, and that is what this whole concept is about. I don't know if you can see what this is, but give me a shout if the presentation doesn't show.
It looks great, Hein.
Okay, thank you. If you look in our industry and also in other parts of the packaging industry, we are a bit of a traditional bunch. We do find new things, but to make real concepts, to think about the future and to show that is not so often done. But in the car industry, for instance, here in Sweden, where I am at this very moment, they do so. You know, this is a concept car of Volvo, and they say it will come out. And this car, you know, this will never be produced. But the concept thought of this is, I find this very intriguing, because what it says, you know, it brings you to work, and you can have lunch, or you can have dinner, or you can have your breakfast and read a newspaper. And you only have to tell the car where to go. You know, that would be a dream come true for me. You know, I could even take a nap in the back, going to the office. So in this industry, it's rather common that you show these kind of things. And in that perspective, you also have to see the comic. It's a thought direction. It's a way of, you know, triggering the discussion. And I was so happy that my CEO gave us the opportunity to develop this, and to work around a concept which could be in the cosmetics industry, and which could replace quite some fossil plastics. When we started, we said, you know, if we do this, it better be 100% wood or wood based. And that is what this comic is about. The traditional paper industry has a lot of solutions in itself. I think that we should be much more outgoing and co-learn and cooperate with new startup, with new companies, because that's where we will find the solution. That's where the future is. And in this case, we've done that. We found this company here in Sweden called Loop, which is in dry molding, and we had a cooperation with a company called Grow in Stockholm, who's a designer. And Woodley is a company from Finland. So me being Dutch with all these Scandinavians, I'm a bit odd in this constellation. But it was a good journey. It was a good learning. Where can we do things? How could we make different packages for the cosmetic industry? And on top of that, could we make refills, because that's not so common in the cosmetic industry. Since 2 years, you see a lot of these things moving, because the cosmetics start to understand that they need to change too. So what we like to think in this perspective, that Eike is a material supplier. We make board, but we also want to explore a bit in the future and see what kind of new materials could come. Where is the future for us? And then, of course, when we look at that future, we wouldn't mind that if you pack the future in a paperboard box, because that's our core business, and that's what we sell. And then, you know, of course, it also has to have a good design. And a while ago, I was invited at a company in Sweden at Sweatboard, and they had stunning material. And when I was talking to the CEO, you know, I said, yeah, I'm going to create something for you, because this material is so good. It has the potential for very good displays, and I'll show you a bigger picture later. Now, when you start working on such a concept, you know, you work in versions. The first version is the one to tease, to test. And then later on, you start thinking, okay, now I need to go in that production line, or I need to go for that barrier, or so you have several versions, and that's okay. I think we should do that much more, working in version, because that gives you the ability to practice with the brand, with the converter, with whoever is involved. And sometimes you screw up. That happens, and then you stand up and go and make the next version. So that is what this conic is about: to learn, to learn about techniques, to learn about other companies, and to learn about other materials. And if you look at that, then here you see a bit of the things. The Loop factory made the lid and a refillable pot. In this case, for day or night cream, whatever you would want. And the Loop factory is working on several options in barriers, but this is just a plain fiber. And the good idea behind this is that these pots are made from non-prime board. We in our company, in the way we produce board material, you always will have some side streams. Now they're coming to use, so that is a real good sustainable story. If you look at the lid of this holder, which you see here, that is Swedish birch. I think that's the best birch there is. And if you look at the holder itself, it looks like glass, but it isn't. This is a concept by Woodley, and they have a cellulose-based plastic. It's in development. It's not there, but I've seen a lot of movement on their side also. So it's good to support this and to have these developments going on. And yes, of course, like I said before, if you look at it, I don't know if you can call board a bioplastic. I would like to. It's a good name. At least it's a biomaterial. And it comes from a renewable resource. There's some more pictures in this. Just this is the marketing part, and I like to show it because I love the design. And here you see what I meant with the sweatboard display. And I think this is what is important. If you come up with new designs, if you want to attract the brands, you have to go a bit further than only making a new box. You have to tease, and design on its own is a very good carrier of that. I learned that in other parts. I was allowed to work in the paper bottle, and there we also saw that if the design is good, you get so much more attraction. The conic concept is an invitation. It is an invitation to brands, to converters, to developers. We at Igesund, we make very good boards, but I think that like Eike Langenberg said, you need to come up with new solutions. You need to come up with new concepts, and that is what we want to do. And of course, we're a bit we're proud of the Green Deal which Europe has. Michael Thielen said that the politicians don't listen. I think the politicians do listen, but Michael, they listen to their voters, and we better start thinking about that, because it's the public and the consumers who want us to change. Lucky enough, this whole Glasgow conference brought a lot of good things, and I think it's to the benefit of the fiber business we're in, but I also think it is a good development for the bioplastics. And if you talk about the bioplastics, then I'm ever so happy from what I've seen now on these two presentations already, because in the past, there was a lot of talking that they were less bad than the fossil plastics, and less bad. That is not good enough. And I'm also pleased that I see an enormous amount of plastics, bioplastics coming. So there must be a couple which bring me the right barriers, because I still need barriers. I don't have that in our board. So we need to cooperate and to co-learn about that. But then if you make a bioplastic, I would give you this thought. Why don't you think about, if you have a good bioplastic and it has the right barrier, could we also add something else? Could we make a bioplastics which would enhance the paper recycling? Take the bar a little bit higher. Wouldn't that be a great thing to do? Anyhow, the challenge is on. I think that the organization has my email contact. So if you have that solution, don't be afraid to contact or my colleague, which I will involve in this. I think that that if we want to have success, then we need to dare. We need to be a bit brave and courageous, and that's what this is all about. I hope that this gives you a little bit of input on where we are with this.
Thank you very much. This is interesting. I have a question here. Is Iggesund aiming for being more of a packaging company with this? I mean, not only a board company, or just going into packaging?
No. It's not our intention to forward integrate, but it is our intention to explore new techniques. We need to see what's going on, and by presenting these kind of concepts, your discussion with brand owners and converters starts to become different. You start to think about what could we do in the future to help you, and that's what this is about. It's not our intention to be a packaging company. We are and will be a board supplier or material supplier, better.
So if this concept becomes a success, someone else will produce it, so to say, the packages.
Yeah, but the base material will come from Iggesund.
Yeah, of course, I understand.
Yeah,
that.
No, but it's you're right, and I'm ever so happy, to support that.
Yeah. One interesting thing here is, of course, you mentioned it briefly, the barriers. How do you follow this development, and what do you see of interest right now? Because a lot of companies are looking for bioplastic barriers for example, for the paper bottle or whatever. What is your view of this right now? Can you see anything that is really interesting and coming up and useful?
Yeah, I think that and when I say this, it's meant in two ways. Under pressure, everything gets fluid. And that means that there's a tremendous load of pressure on the development of barriers, whether bio-based or biodegradable or whatever. And I do see, let me put it, for our industry, the board and paper industry, that in the dispersions, there we start to see several options. Either it's by a form of printing a barrier, or by spraying, but there is where I see a lot of movement. And for our industry, of course, because we work a lot in reels, that will be a terrific solution.
Yeah, and you're also developing barriers yourself, so to say. It's not only looking at the market around you.
Well, we like to co-learn and to cooperate and discover things. Yeah, yes. Of course.
You said something about Woodley, and you said it isn't there yet. What did you mean by that?
Well, we discussed this with Woodley, and the honesty is that what you see here is a rendering. We have all these pieces also in hard copy. But the outer piece was not made yet. That has to do with resources. Everything costs money. I'm ever so happy that I see now that Woodley has made small rigid bottles out of their material. So it is there. We could now order a tool, but you know, it's budgets and tooling. So probably I have to postpone to next year, unless I get paid for this presentation, and with that money I can buy a tool.
Yeah, dream on. I can only say dream on. No, but that I mean the Woodley products will be with finished fibers. It's not going to be Iggesund fibers or.
No, that could be discussed, but that is not the intention. No.
I see. Okay, I think we have to stop there, and I would like to say thank you to you also, Hein, and we'll keep in touch some way or another, I hope, for the future. And we're going to go over to the last speaker today. So thank you very much.
I'll be gone. Bye-bye.
Bye-bye. Bye-bye. And now we are going to the, as I said, to the last speaker, and it's Mr. Alberto Castellanza from the company Novamont. And many of you might know that Novamont is one of the really old timers in the bioplastic market, and maybe one of the first companies that was actually commercially available a long time ago. And their brand name is many times it's Mater B. And Alberto is going to talk about new developments in flexible packaging. And that sounds exciting. So, Alberto, buongiorno, Italia.
Buongiorno. Can you see me? Can you see my presentation?
Yes.
Yes. Are you able to activate my video? I will, if everything's okay, I will start. Okay?
Okay.
Thank you. Buongiorno to everyone. Thank you both for the introduction and also for the kind invitation. For just a moment, I need to activate the video. And my presentation will be focused on a general overview of what Novamont is developing in the sector of packaging, in a flexible packaging, and I will try to touch some points that has been already touched by Hein, for instance, in terms of in which way the industry of bioplastics is facing the challenge to improve properties, barrier properties, different performances in order to reach a level of performance that is in line or even above properties of standard plastics. But before this general overview, I will spend a very few words about Novamont. So just a moment. So first of all, Novamont is since last year, 2020, certified as B Corp. We are very proud of this achievement because it's a sign of how Novamont is working in different levels in order to combine his main mission, that is the production of byproducts, bioplastics and biochemicals, but also obtain a biointegration between the chemistry and the agriculture, but also on looking at the benefit of the total, the society and the territorial regeneration. So we are willing to prove also our commitment, showing proudly this kind of achievement in terms of certification, like it is a B Corp certification. Novamont is an Italian company with a very strong and very well established industrial structure. We are producer of biochemicals, monomers coming from renewable resources, so from agricultural feedstocks. We are producing polyesters, and we are compounding. So as Bo mentioned, our trademark is Mater B. Under the trademark of Mater B, we are selling all our range of products. We have more than 50 different grades of Mater B, totally biodegradable and certified compostable for different environmental conditions. The second important part of our group is research and development. We are, since the beginning, in our DNA, research and development at different levels is a key point. We have 3 research centers and a number of patents that are able to protect our technologies from basic chemistry, so from the production of monomers till the final application. But we are also a very important training center. We are working with several universities at the international level, and our aim is to grow with the students, with the universities, the concept and the culture of bioeconomy and biotechnology. These are our three pillars. So we are, since the beginning, our philosophy was to work at industrial level in order to recover industrial sites that otherwise are not able to be competitive anymore in a global chemical market for different reasons. Technology of these plants are obsolete. They are too small to be competitive with the other, bigger and more advanced compounds in the chemistry. So there are several hundred different sites all around Europe with that are in this position. And our idea is to show how to convert this kind of plants into using new technologies and trying to create an added value on the product that they are producing. The second, as I mentioned, is the connection with agriculture. We are working with farmers, not only in the sector of end of life, so not only in the product in the sector of usage of plastics in agriculture, but also with farmers in order to optimize our crops, in order to optimize the selection of crops and obtain something that is has a better yield, better in our biorefinery, and also creating a value for all the collaboration, including the farmers and farmers association. The third point is more related to product, so more related to the presentation that I'm giving. So we wanted to follow, and we want to develop solutions that are not only replace one-to-one to the current packaging products. For instance, we are talking about packaging, not only a one-to-one or drop-in solution, but it is something that is going to solve or mitigate, reduce the environmental impact of packaging application, for instance, or in agriculture or in other sectors, working on the concept of eco-design and working on the concept of looking at a very careful analysis of all the environmental impact, and also with important focus on LCA studies. We are located in Italy, as you can see on the left side of the screen. We are based in Novara, and we have three production sites, another research center in the south part of Italy, and we have a network that is covering different offices. We have 4 offices all around the world: Spain, Germany, France, and in North America, and a network, a very efficient network in sales all around the world. This is a very quick overview on our range of products. So we are working on solutions that are focusing on, as I mentioned, a new approach of eco-design of the products that are looking not only as a product as it is in terms of performance, in terms of bio properties, but also how this product can be disposed in a proper way in order to solve problems during the end of life. And our range of products are coming from large retail market like fruits and vegetable bags, shopping bags, cling film, packaging for fresh product. Of course, the key point is a separate collection of organic waste and the use of Mater B bags to collect organic waste. That is the most important part of our capability to go into the market, because it's a link between bioplastics, biodegradable and compostable plastics, and a waste treatment, but also agriculture, packaging, food service product. So every kind of article that can be used in a canteen, in a restaurant, the key point is, as already mentioned in previous presentations, the possibility to collect and recover organic waste thanks to the combination of different products in a compostable version. Then other kind of food packaging, including coffee capsules, but also new sectors like cosmetics, ingredients, and biolubricants and bioherbicides that are not strictly related to the sector of bioplastics, but are part of our common project strategy of developments in different sectors, with always the same concept to reduce as much as possible the environmental impact and the possibility to use renewable resources in all the sectors, including agriculture, in industry, and in the cosmetics. And this is the reason why we are focused on the packaging. Why we believe that compostable packaging can be a good solution. Is a good solution when there is a possibility to link these products into a well-established schemes of collection of organic waste. And this is the most important part of all the strategy and the successful, the secret of the successful developments of all these kind of products. But basically, why we believe that flexible packaging, for instance, can be a good solution. First of all, because in most cases, multi-layer materials are not recycled, are combined with a different kind of products, different nature of polymers. In some cases, there is also an aluminum foil, and it's very difficult or almost impossible to be recycled. Another point is the size. When we are talking about the small size of the packaging, like this kind of packaging of this kind of napkin, it's very difficult for sorting systems to collect, detect, and dispose in a proper stream. So the size is extremely important. And small packaging are, for us, for our vision, are much more open and easy to be disposed in organic waste collection into the brown bin. The last, but it's most important, as I mentioned, in the case of food service, is the food contamination. Every time, in every case in which there is a possibility that the packaging is hardly contaminated with food, recycling of the packaging is becoming very complicated or very expensive. The possibility to collect everything in one common stream of organic waste into the brown bin can be a good solution. And that is the reason why we wanted to work on that, because the focus must be more and more on what the possibility to use compost coming from the organic waste treatment, good quality of organic waste, to improve the quality of the soil. We mentioned before during some of our previous presentations which are the possible schemes, which are the possible options for biodegradation of plastics or bioplastics, meaning biodegradable plastics. And we believe that what is important is to look on how bioplastics, compostable plastics, can be a system, a tool, an instrument to increase the quality of compost, increase the quantity of compost, with the possibility to introduce organic carbon into the soil and reduce the trend that we face in this moment, of the soil that is getting poor and poor because of a lack of organic material, organic carbon, poor because of very high and very strong process of erosion, and that this is something that can be activated thanks to the introduction of a new material like a compostable packaging. Now I enter more into the topic of my presentation. This is a general overview of our packaging applications. We are showing some examples that you can find on the market with some brand owners. So we are working on flexible packaging, transparent packaging for with the barrier properties, multi-layers, combining different structures, different materials with a transparent printed film, a sealing layer. In some cases, we are working on a seal with the layers, with the sealing layers that are a combination of coax structures, including some EVOH and barrier properties. The second is a combination of a rigid tray, is made of matter B with very good properties in terms of barrier properties, and outside a lid made of PLA. The third is a salad, so compostable bags for salad is a kind of replacement of barrier-oriented polypropylene. We are working in increasing more and more the clarity of the product, but it's working very well in a very different machineries for form and vertical, and also in some cases also horizontal form and fill systems. Then there is a product developed with some Italian converters for compostable cling. It's performing very well. Is very good cling effect, and also very good clarity. Compostable capsules. We are working on this case is an injection molded capsules, and we are working with some supermarkets like Coke in Italy, and products are already on the market, are fully compostable, and are very well accepted, and is a perfect product into the scheme, into the concept that Novamont is promoting. So the idea to use compostable packaging, coffee capsules are not properly packaged, but compostable products in order to collect and capture more and more organic waste, and coffee is a very good source of resources for compost and for the quality of the final compost. And then a combination of our cling film with the paper trays, and that's something that is already on the market. This is with some more details of the application that we developed with some brand owners in Italy. It's a combination of different materials. We are working now on metallization, combination of a metallized matter B film with a paper in order to work on and develop a specific packaging application, for instance, for snacks and for other small packaging that you can see here on the slide. Again, very nice applications, because this is a case in which we are working with these brand owners. This is one of the most important apple grower in Italy, in a specific packaging, but also in order to develop a secondary application of scraps in working the process of fruits, and get from them some important feedstocks for our manufacturing. Again, this is the tray that I explained is already on the market, and is extremely important case of a combination of different materials, very nice, rigid and performing tray, and a very transparent film that is made of PLA. And that is the package of green salad. Is beside the runnability and the printability, it is extremely interesting, because the formulation, the composition has been done in order to reduce also the fog effect. So it's a product with the anti-fog performance. I finished. If you have a question, I am at your disposal.
Thank you very much, Alberto. Also, a lot of information in short time, but very interesting. Because we have passed the deadline, so to say, we should have finished already, but just one or two quick questions here. The question is coming back from the same person as before. Again, are any of these plastics available as dispersions, for example, for printing, painting, or coating?
Yes, we are at a very good level of stage of developments of matter B for dispersion coating. we are working with several partners in the Nordics in order to validate the commercially available applications of a dispersion coating, direct dispersion coating also, but also trials in the pulp. The goal is to give some additional features to paper or paperboard in terms of sealing, in terms of foldability, for instance, or forming, maintaining the concept of a compostability. So we are working on that, and I would say that the concept of the dispersion coating in the concept of a plastic-free product is something that is extremely on top of the priority of different paper companies in the Nordics and in the sector of converting.
All right. Last question. Some people are concerned about the contamination of the recycling stream of conventional plastics by the compostable plastics. How do you see this issue? Thanks.
It's for sure, it's a topic that is in a phase of discussion, so is on the table, also at the political level. We are able to show that, first of all, bioplastics can be sorted in a normal system, sorting systems for recycling of paper, of plastics, sorry, of a plastic. So is are not can be in case there is no problem and that can be treated as normal plastics. So sorting from a polyethylene to others. In case of direct recycling, we have a number of tests, including a third-party test like done in Italy by the Italian consortium of packaging collection, showing that even at a very high level of a percentage of matter B into the stream of plastics is not creating a negative effect. So this is something that it can be developed as a concept, but we don't believe that it is a main issue in terms of the acceptance of bioplastics into the general stream of plastics, considering that for us is the priority is to collect compostable packaging in a stream of organic waste. But in case we see that there is no problem in all the process, sorting and recycling.
All right. Thank you very much, Alberto. There are some more questions, but you will have to answer them later because time is running. So I think we have to stop. Thank you very much.
Thank you
for
Bye-bye.
participating. Bye-bye.
Bye-bye.
Okay, everyone. I would like to say thank you to all the speakers, of course, for participating here and giving us such wonderful and interesting information. I hope it gave you some good thoughts about bioplastics also. We are going to end up here. I just want to take the opportunity to wish you all, even if it's a little bit early, Merry Christmas and a Happy New Year, but we will not meet again, at least not on a webinar format before Christmas. So I hope you will have some good weekends coming up in a couple of weeks. And let's hope, I think I said this last year also, let's hope for a better year next year if we look at the pandemic situation. It looked very hopeful for a while this year, but now we seem to be back in big troubles again. And so do the vaccination, that's important. And please stay safe. We will come back after New Year and with more information about bioplastics and with information about our annual meeting where you are all welcome. So please, thank you very much for participating. And as I said before, in a couple of weeks, you will be able to see this again, and you will also get some answers on the question that was not answered today. Thank you very much, and bye-bye.
Bye.